Okay, so you're going live. You hear me?
Yes, I am.
All right, okay. I think you'll get a little delay. I have a short delay in YouTube. Go fancy again. Okay, so you want to start looking at some logarithms. But what I'll do first, I'd write down a few questions because what I'm trying to really do is right. I want to make sure and assess. I want to assess you all to know how much we have to do in logs, right? Okay, guys.
Yes, sir.
And I end them at all. Okay, so let me just open OneNote first. I'm going to look at logarithms and incidentally, Jamil, you got any problems with any of the questions?
From last one, yeah, a few from last week.
Oh, yes, no. Jamil, 1 second, boy, 1 second. Actually, I'm not hearing a word that you're saying because I didn't set my microphone. Yes, no. Yep. And I'm setting it to you. Right. Jamil, you hear me?
Yes, I am.
Beautiful. Right. So, right, we're doing some log. We're doing remainder factor theorem and all the different implications of it. And I felt, even though we haven't done all, I felt we've done quite a bit, so we can move on to something else. So what I am going to do, I'm going to talk about logarithms today. So I'm going to add a new section here. This one is logarithms, which is really is part of really surge logs and indices. Now, I know it's a topic you would have done in school already, so what I am going to do, is just check through some questions, gradually increase them in difficulty and see if you all could work them. But we see we have problems, we know what we have to do. We have to dig into them. Okay, so let's get started. So, oh, okay. All right. Search logs and indices. Search logarithms and indices. All right. And if we accept a comma. All right. So let's go. Yeah, we go. Share. So you see my screen?
Yeah.
All right. Okay. So you see my screen there. All right.
Yes, sir.
All right. So I'm gonna write down a few questions, and if you can figure it out, I know I don't have to do this kind of stuff. All right. Let's say I give you something that looks like this. Could you solve that sum? Fancy. Okay. What about you, Jamil? Could solve it?
No, sir.
All right. Okay. Well, this is just an application
Up and
of
down, certain
root of A by root of B is root of A B. So the answer to that would have been root of 6 by root of 1.5 is actually root of 6 times 1.5, which is 3 and 2, as root of 2 into 1, 2, 2 into 6, 3. And the answer would have been 3. You remember seeing that law at all before?
Yes, sir.
Or you can fancy?
Yeah.
All right, okay, so then, okay, let's try another one then. Because why I'm doing this, I'm going to see how much I'll have to work with yours. I'm gonna put that down there. All right. Let's get another one. Let's look at this one. What if I give you something that looks like this? Root of 48 plus root of 147 minus root of 75. And I ask you to simplify that. Can you do that one? I'll give you a minute. In the time being, I think I'll make an electronic copy of let's give you a minute to do that, if you can. Fancy.
Yes, sir.
Think you can work that one out?
Yeah, I believe so.
Okay, what about you, Jamil?
Yeah, easy calculator.
No, it's without a calculator.
Oh, then nah.
No. Okay, Fancy, what ideas you having in doing that? Let me hear. What ideas you having?
It actually just now.
I got my advanced notebook and I look into some of the notes. It's a long time we didn't do in advanced. So I just refresh in my mind. But looking back here,
Clinical like
what we could do is the additions.
for the
Break down these
yeah.
square roots itself first, down to the lowest we could get it to, and then do the actual additions and subtractions.
All right, so tell me what to write. I'm all ears. Go ahead.
So for square root of 48, the teacher taught us you could break it down in such a way that, like, say you have square root of 18, what two square roots will give you square root of 18? It will be like square root 9 by square root of 2.
Okay,
So
well,
in this case, square root 48 will be a square root of a number multiplied, right? Like, what number we could use? Yeah, 8 and 5, 8 and 6, and use 6 square root of 6 by square root of 8.
okay.
And then for 147, you find two square root numbers that will multiply to get this. So
No. What you're doing is kind of correct, but we kind of. I ain't going with that. Okay, what you do in such a situation, just a reminder, look at the three numbers you want to find the root of in questions like this, and see if you can find the LCM of them. I could see that not LCM, look for common factors of them. If you could get the highest common one by just looking at them, that's even better. But I can see clearly that 3 could go into 48, 3 could go into 150. So if we take away 150, 3 from 150, 3 could go into 147, 3 could go into 75. So I can see 3 could go into all of these. So I say this is actually like the root of 3 times 16 minus the root of 3 times 49. Sorry, plus the root of 3 times 49 minus the root of 3 times 25. And then you know that the root of this here will be root 3 by root 16. And this one will be root 3 by root 49. And this one will be root 3 by root 25. And you can clearly see in all three that the common factor is,
3.
yeah. And then these numbers are actually perfect squares, these three. So what's the root of 16?
4.
Yeah, 4. So that's actually 4 root 3. And yeah, what's the root of 47?
49. It's 7.
7 root 3. And 25?
5.
5.
So you have 4 of something. Yeah, then 7 of the same thing. But you're taking away 5 of the same thing. So that'll be basically 4 plus 7 minus 5
6.
into root 3.
6 root 3.
So that's 11 minus 5, that's 6 root 3.
Oh.
That's how simple that was. Okay? So you're supposed to kind of know that. I'm assuming you would have done that in school. Let me give you a next one. And no, why I'm doing this, I'm just want to see how much I have to teach you all, right? That's basically the aim. That's basically the aim. So let me zoom out a bit. All right. If I ask you now to do something like this, just change it up a bit. I make this one root 50 plus root 72 plus root 60 what's the sign here? Divided by root 5. I'll give you that one to do. Let's see what you will do there. Too difficult? Jamil, too difficult?
Well, probably, yeah.
No, why not? No.
I China, sir. I China.
All right, I want a better fighting spirit from all them, man. Yeah, so let's try it. That's correct. Problems?
I a little bit more
I
time.
will,
Kafensi get through?
I will,
Yes or no?
no, sir, not yet.
Okay. All right, let me. All right, so that's how the scorecard. Okay. All right, so let me give all you a hint then. Okay, let's give you all a hint. So our hint, the root of A, B is equal to root A by root B. Also, the root of A over B is the root of A divided by the root of B. That should give you a hint. And of course, these two are connected first because in any algebraic equation, division is done before addition.
I see. Yeah.
Finished?
Yes, sir.
Kafensi, finish? Kafensi. Kafensi. Okay. Let me work it out. So this root,
Sir,
yes. So this be root 50, obviously, plus root 72. When you work out this part in yellow here, that's plus the root of 160 over 5, which is root 50 plus root 72 plus root 32. Make sense?
yes, sir.
I see 2 could go into 50, 2 into 72, 2 into 32, so that's 2.
Yeah.
I think I agree that's 2 root 25.
Yeah.
This is 2 root 36. And this
Plus root
is 2
16.
root 16. And all these numbers are perfect squares.
Mm-hmm.
And so what we see here, we're not even getting a third. We're getting 2 times 5 Also, it's root 2, sorry. Right?
Mhm.
Root 2.
Mhm.
Root 2, right. So you get root 2 times 5 plus 6 plus 4. That's 14 root 2. 15 root 2. That's the answer. Okay, so what I've generally recognized then is that you all don't really
So I got the answer.
recall, you all don't really recall what you all did in surds as well. All right, so, oh boy, what did I just do here? All right. Okay. Kafensi, can you hear me? Okay, let me see what happens. I think I got a message in WhatsApp there. Kafensi, are you there? Oh my goodness. All right. Are you seeing him frozen on your screen too, Jamil?
Yeah, so he frozen.
Let me see if I could message him in this boy. Okay, yes, I probably can. Right, so now I can send a message. All right, so I just saw Kafensi look up. Kafensi, what happened?
Yes, sir.
Uh, you got any question? You got any question? All right, okay. Well, Kafensi, if you're doing thing after, you could watch it on YouTube, right? I'll give you the YouTube link for it after. All right, so let's roll because we have plenty to do. So far, what I'm seeing is you all have not you all did these things in school already, or you did not?
Yeah, but
But
just can't remember.
okay. What about if I ask you to do something like this? Just want to make sure we kind of did some stuff. So um, let's say I ask you to, I'll give you 2 plus root 3 all over root 5 plus root 11. All right, let's say I give you some of that. And I ask you to rationalize it.
Oh yeah, if you had to multiply both sides by the
Can I
denominator.
call me, say? Can I call for mommy?
All right, go ahead.
Yeah, so you have to multiply both sides by the denominator. One, like it'll be root 5 minus root 11 divided by root 5 plus root 11, I think.
Oh my goodness. Jamil, no, 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 no. You're almost there, but you're not there. Okay, so you know what happening? Well, yeah, let me just run through these basic third formulas and all that, right? Well, basic. All right, so let me go back to the top because I was trying to assess how much you all could remember. So let me take all this off the screen, all of this. I'll take that off and let's just do that. Okay. All right, so basically, a third is the root of an it's a, let's write the rules, yes? Okay, so um, the root of a number a mm, times root of a number b is equal to root of the product of them both, a times b. The root of a number a divided by the root of a number b is the root of that ratio, a over b. Obviously, this does not apply, right? What is not the case, the root of a number a plus the root of a number b is not the same as root of the number a plus b. That's not allowed, neither if you subtract them. It's not equal to the number a subtract b. Okay? Now, based on these two up here, what we do know is we could extend that law just as we use the root of a number a times root of a number b times root of a number c will be the root of a number. If you look at these two, we know that's the root of ab times root of the number c, and that will of course give us root of the number a times b times c. Okay? Right. Similarly, root of a number a by root of a number b divided by root of a number c by root of a number d can be written as take a and b and find the root of that and divide by the root of c times d. Okay, these two go. They are correct. All right, remember that these here are not correct in that box. Okay?
Yes, sir.
Right? We also know that we use this property that if I get an expression, any expression that we have, if you multiply it by 1, we get back our original expression. So anything by 1 gives you back itself. Any expression, be it a surd, an equation, an inequality, anything multiplied by 1, you get back whatever you multiply by 1. Make sense? Right. And 1, bear in mind that 1 will be equal to some expression, a next expression. All right, some expression with a star by it all over itself. Anything divided by itself will be 1. That is granted that the expression isn't 0. Granted that expression, whatever it is, cannot be a 0. So 0 over 0, in other words, is not a 1. It cannot be equal to 0. Right? 0 over 0 is not a 1. Right? So you can't use that. But any expression divided by itself will give you 1. So we use that. We use a few things we know. Some laws in algebra. First one you're going to use is that a plus b all to b squared is a squared plus b squared plus 2 times a times b. That's always true. Got an identity. We also know that a minus b all to b squared looks very similar. It's a squared. You also add in b squared, but this time you'll be taking away the same 2ab that you were added there. And a very, very important and useful one, the one that tends to be most often used by us is that a plus b into a subtract b is always equivalent to a squared minus b squared, the difference of two squares. We tend to use the one on the bottom. We tend to use this one to help us rationalize, that is, move certain signs from the denominator of fractions. Use this one here. Okay? Now, these are facts that are taken from basic algebra. All of these here are facts taken from basic algebra here, so we put a nice little box around them. All of these are facts that, oh boy, all of these are facts all of those are facts taken from basic algebra. Oh my goodness me. Wow. Right. Let me zoom back in now. Right, so this has nothing to do with, well, I shouldn't say it has nothing to do with surds. It doesn't apply specifically to surds. It applies to everything in mathematics. Take an expression, multiply by 1, you get back, you get back the same expression. Now, if we try to do things like this, using the same a plus root b into a minus root b, right? Or let me do it differently. Let me use different numbers so you can see the connections. Let's say I put x plus root y into x minus root y. Why I'm using x and y? Because the formulas I've just quoted up here, all the formulas I've quoted up here, let me see. All the formulas I've quoted up here and so on involve a and b. Okay, so I don't want to use the same letters, so I'm using x and y. The fact of the matter is you can say this x here behaves like an a, it behaves like a a, and this behaves like a b.
Y.
So that's a plus b, and I can say this is like a minus let root y be b. And I know for a fact, using my formulas, that a plus b into a minus b is a squared minus b squared. So my outcome here will have to be whatever a is. A seems to be x, so I'll get x squared. And I'll get a, y is like b, so I'll get minus root y squared. And the answer will actually be x squared minus y. That making sense, all yeah?
Yes, sir.
Can see that making sense?
Yes, sir.
I'll let the x behave like how a is, and the root y is like b. So if they give me that to multiply, I don't have to go and expand it all out and stuff. I could see that looking like, it looks like, yeah. When I look at the structure of this, if x was a and root y was b, this is like a plus b, and so it'd be like a minus b. The answer, multiplying a plus b into a minus b, we know is what? A squared minus b squared.
Yeah.
So if a was x and root y was b, when I multiply these two expressions, I'm sorry, let me just put in this here. Right. I multiply root a plus b into a minus b, and I'm supposed to get a squared minus b squared. So x plus root y into x minus root y, and I'll get x squared minus root b is root y, so root y squared, and root y, all to be squared will give me y to the power 1. That makes sense? Fancy?
Yes, sir.
Yeah. Right. So things like that, we have to be skillful in using things like that. So let's say they give me now x minus root y all to be squared. And ask me to simplify that. I could say this, I have a subtraction going on here. And if I use different symbols, this x could have been a for all I know, and y could have been b for all I know. And so the answer, the structure of the question would be like a minus b all to be squared, for which I know the answer is what? A squared plus b squared minus 2ab. So I know when I compare what those are there, I can say x, if a is x, the answer will be what? And the answer will be a squared plus b squared minus 2ab. What is a? X. A is x, right? You agree?
Yes, sir.
So I get x squared there. And b is what?
Square root of y.
Square root of y. But when I square that, I'll get y, right?
Yeah.
Yes, sir.
So I get plus y minus 2
X
times x by
Square root of y.
square root
square
of
root of y. Yeah. Right? So use things like that to help you. Right? That makes sense so far?
Yes,
Yeah.
yes,
sir.
sir.
All right. Okay. So let's now then you have some questions you have to rationalize stuff. So they'll ask you, like, for example, 5 plus 2 root 3 all over,
I'll come back.
sure, 2 minus, 3 minus root 7. And they'll ask you to rationalize that. Rationalize means get the root sign out of the denominator. All right, the master to rewrite it, the master to simplify, the master to rationalize that. Now, this expression here, if you have to rationalize that, you can say, well, this, you can clearly say, write this sum over. You can say, I'm not going to write it over, I'm going to just copy it. So my answer, I can write that will be equal to that, all in brackets, times 1. You agree that, Kafensi?
Yes, sir.
Right. And then I use the fact that 1. Now, by the way, whenever I use the formula, I want to show you a nice thing about the difference. And anyway, I'll compare that after. All right. So, yes, I'm saying that's the same as that times 1. It's my solution here. Start my solution here. And I'm saying if you ask me to rationalize this, yeah, this obviously means that on top minus what's at the bottom. And I'm saying the entire fraction will be the same times 1. That makes sense?
Yeah.
The thing is, I want to make a convenient choice. So I use a convenient one. So I use a tricky one. A convenient one is a one that will make my problem look a little simpler. So that convenient one, right, that convenient one actually will be anything over itself. I'm deliberately going to choose 3 root 7 because I see 3 root 7 here. Because I'm seeing 3 root 7 here, I'll choose 3 root 7, 3 root 7, but I'm not going to subtract them as I'm doing here. I'm going to add them.
Yeah.
I'm going to add that. Why? Because the bottom has this structure now, the denominator. Now, do you agree that this over this is 1? Do you agree that this is actually 1?
Yes, sir.
Right, that is 1. So I know that my answer will, I've violated no mathematical law. Right, I'm in good standing. I'm keeping all the laws. Right? Why did I choose 3 plus root 7? Because the two signs, this sign here and that sign, positive and negative, it gives you the denominator the form. This denominator here, all together, now has the structure a plus b into a minus b. Make sense? And what happens whenever you do that? A plus b, a minus b always get squares. Right? You always get squares. So if you had any root sign, when you square it, what will happen to it? It will disappear.
The normal number.
Yeah, root signs disappear when you square all root signs. That's what you want. Right? So you'll have no root signs then in the denominator and expand it. But more importantly, the math gets very simple because you know the outcome of a plus b into a minus b is always going to be what? A squared minus b squared. Okay, so a little thicker. Right, so that's actually going to be the top is going to remain 5 plus 2 root 3 times 3 plus root 7. Okay? The bottom, however, is in the form of a minus b into a plus b, which you know is going to be what? A squared minus b squared. A is going to be
Yeah.
3, right? A is going to be 3.
Yeah.
So a squared will be
3
3
square
squared.
minus 7
And you have
minus 7.
you have root 7 all to b squared. Root 7 is b. So when you square it, you will get 7.
Yes,
That
sir.
makes sense?
Yes, sir.
Right. Once you do this technique, you're guaranteed to have no square roots in the denominator. So anyway, now you have to simplify that. So that becomes 3 squared is 9, root 7 squared is 7. So this actually becomes 5 plus 2 root 3 into 3 plus root 7, all divided by 9 minus 7, which of course is the same as 5 plus 2 root 3 into 3 plus root 7 all over 2. Make sense?
Yes, sir.
Yes, sir.
Yeah, and then let's do the top now. So it's a 5 by 3, 15, 5 by root 7,
5 root
5 root
7.
7, 2 root 3 by 3, 6,
6.
6 root 3, and root 3 by root 7 is actually root 3 times 7 or root 21. That makes sense?
Yes,
Yes,
sir.
sir.
All over 2. Yeah, I don't think that can be simplified any more than that. That's it. But what we have succeeded in doing, if you notice, the answer has no root signs in the denominator. We call that rationalizing
The root
an
21
expression.
could be 7 by 3.
Yeah, but it could be 7 by 3, but that's how we got it actually. We took this guy,
Oh, yeah. Yeah. Yeah.
multiply that guy, right? That's how we got him.
Yeah.
Right? But we really can't simplify it any more than that. There's some questions that they give you where you simplify a little better. But the general idea is that we got rid of the root sign from the denominator. Make sense?
Yes, sir.
Those are the basic rules of surds. They have not much more to surds than that.
Yes,
Right?
sir.
So, but you have to be able to extend that kind of thinking. Use expressions like what I have in this box here. I understand how to use that. Understand, of course, that. All right. So once you understand those things, that you should be able to do a little exercise for me. Let's pick out a few questions in an exercise. You should be able to do that.
Sure.
FNC, what do you think?
Yeah, I guess so.
I think so. But you know what? Let me start with a sexy past paper. All right. So okay, let's see. Okay, so let's see. All right, so we want to do. All right, so I think going to the past papers might be helpful. What do you all think?
Yeah.
Yeah, let's
Yes,
go to
sir.
our past paper and see how that looks. So let's see. So what you see on your screen there?
Two people doing a maths thing.
Oh, you don't know what that is, huh? Okay,
It's
so
CFC past papers booklet.
yeah, that's the past paper booklet there. Okay, so I'm looking for surds. Surds normally comes in the first section. Wow, no surds. All right, so let's go to the next here. Okay, this is the practical paper. No surds here either. Logs tend to come much more than surds. It's a practical paper. No surds here as well. Wow, that's about 3 years so far. Okay. It's almost was a surds question, but it's not. Let me check one more year. If you do have surds here, then you'll have to go to multiple choice paper to get some surds questions. This question almost is a surds question, but it's not. They have more logs than anything else in that one. All right, so let me just go down. Wow. Okay, these are some of the more recent years now. If I've seen any surds there, and logs, no surds. That's what we have here. Let's see. Wow. Okay, this is practical paper. Let's look for logs. Let's look for surds. Whoa, no surds. Oh boy. Nope. Nope. Very interesting. So when do bring surds? UCX will be devastated. Okay. So let me then get a question from another source. Okay, so hold on, bear with me one sec. I'll have to go to GC past paper, it seems. And we'll get some surds questions there. They actually will tend to give quite excellent yes, let's see. That's interesting. It's very interesting. All right, it's not recognizing this drive. It's not spinning. Let's try one more time. Okay. Okay, it should pick up the drive now. All right, so let's see. GC add match you're looking for. GCE. Okay. Okay. Woo, this is really interesting. Okay. Oh boy, I tell you. Okay, so let's see. 2002 to 2010. That's what we have there. Oh shucks, who tell me to open that with this? Okay. Open my withdraw board. Right, so all right, so let me see what I have here now. So I'm gonna put you all back in. So you see my screen now, right?
Yes, sir.
Okay, so I'm looking for the third question. So eventually you want to be able to do questions right. So here we have a third question here. Let's look at it. Oh boy, this is powerful. See number 4,
Yes, sir.
a rectangular block has a square base. The length of each side of the base is root 3 by minus root 2 meters. See number 4?
Yes, sir.
Yes, sir.
Yeah. And the volume of the block is 4 root 2 minus 3 root 3 meters cubed. Find without using a calculator the height of the block in this form, where a and b are integers. Feel you can do that?
Yeah, try it.
Yes.
Think so?
Yeah, I think.
Yeah, okay. Give it a shot. Incidentally, for us to get good practice, I'll have to I'm going to give you all some of these GC past papers here, because the standard of the questions actually in many cases are a lot higher than what you have in CXC. My aim is when you're done with that exam, it must be like old Mother Hubbard cupboard. They must be dry. All the marks, you must have eaten up all of them. Right?
Yes, sir.
You should be able to do number 3 as well, right? Not so, Jamil?
Yes, sir.
Look at number 3. If you could do number 3?
Yeah.
All right, okay. Now, what I'm going to tell you is, okay, so just pause for a second, you guys. I want to show you all something. This is how GC past papers used to come, right? Now, I remember when I did my exam, incidentally, Jamil, I went to your school. I went to Naprima, right?
Mm-hmm.
Anytime when I was going, there was a teacher whose name was Fayad Ali. He was my maths teacher. Anyway, by the time I wrote CXC, in all my exams, I worked with the exam within an hour. Paper was 2.5 hours at the time, and not just 2 hours. And my papers I worked within an hour. And there was an invigilator. That's the people who come and supervise the exam, right? Normally, people who are not ready going to the school, CXC will pay people to come and moderate the exam. Normal people on the street. So there's this lady in the exam room observing me doing all my exams. And all my exams, no matter how long it was, I finished it in an hour, hour and a half, hour and a half, leaving the exam with an hour and a half to go, and so on. You're not allowed to leave the exam until half an hour has passed. In my multiple choice exams, I leave all of them at half an hour, because I finish all of them within half an hour. So the woman watched me and said to me, "Oh gosh, boy." She said, "Boy, what's wrong with you? Why are you giving up so? Why are you working all the exam? Why you do your mother that? Try now, boy. Try. You give up already?" I said, "Lady, Kobo circling them exam, dead. Have nothing to eat on them exam. Nothing at all. I want you all to train yourselves to do things like that." So why did I give you that whole long, ridiculous story? Okay. Why are we doing our review? I need to be able to measure your skill level from very early up. Right? I need to be able to measure your skill level. So I want to show you all something here. Okay? I have a highlighter here. It says the total number of marks on this paper is 80. Seen that?
Mm-hmm.
You guys
Yes,
seen
sir.
that? Right?
Yes, sir.
And then we are seeing here, a length of the paper is 2 hours. So, quite literally, you have 120 minutes to get 80 marks. Okay?
Mm.
Yes, sir.
So the rate you have to be working back at in order to finish your exam is, if you have 120 minutes to get 80 marks, then if you divide them into each other, that'll give you 2, I'll give you 3. You have 1.5 minutes. So you have 1.5 minutes per mark. If you look at that rate, where you're getting 1.5 minutes a mark, you'll just finish the exam with a second to spare. If you're looking at this speed. 1.5 minutes a mark. So with that in mind, when you look at the paper, what you can see is that this question here, number 5, it's worth 5 marks. I should take 1.5 minutes to get a mark. So for 5 marks, I think I need to do what? I need to look at, yeah, for 5 marks, as 1 times 5, I need to do 1.5 times 5. This shouldn't take me more than 5 times 1.5 minutes to get 5 marks. That makes sense?
Yes, sir.
1.5 by 5 is what? 7.5 minutes?
Uh-huh.
7.5 minutes for 5 marks. And it's even better when you put it down in seconds. 7 sixes are 42. That's 420. And half of a minute is 30 plus 30. So you have basically 450 seconds to work out this question. So when you want to check your pace and so on, you must be able to sit down, read what the question is asking, write all your statements and get the answers in that period of time. Right? And you can do that for every question. So for this one should have taken me 6 minutes, 4 by 1.5. You with me?
Yes, sir.
This one should take me nothing more than 6 minutes. This one nothing more than 7.5 minutes. And so on. So as I use the CXC questions now, GC questions, we know this is what the kind of time frame we'll be looking at. And then we'll know how fast and how effective we are. You should finish the exam with time to spare and to be able to check over. That makes sense?
Yes, sir.
So looking to get up to the level where you also get out the question within 70% of the time allotted to the question. So for this one, it's 450 seconds, but you should really get it out in 70% of the time. If you can do that, I know you are a student. 450 seconds. That's 7 by 45, right? That's 70 over 100 by 450. That's 7 over 10, 7 to 45. 45 by 2 is 90 by 4, 360, that's 315. You shouldn't take more than 315 seconds to work out that problem.
Yes, sir.
Make sense?
Yes, sir.
Which is really 5 minutes and 15 seconds. Okay, so, right, so I haven't said that much. The question, it's really simple. Give it a shot. I give it earlier. The full 450 seconds. All right, the full 7.5 minutes to work it out. Then I'm going to stop and we're going to see where you're at. Okay?
Yes, sir.
Start now. How far you all are from finishing?
Mm.
I have no idea.
Yeah, I know.
All right, okay.
Ah, what is this? What? Before. Getting someone. Which is what the equation is.
Will you get through?
No, sir.
No, sir.
Nah, man. All right. Okay. Well, I've seen some kind of madness on the screen here. You all seen the chat?
Yes, sir. We've seen it. Let's see who's on.
Oh Lord, I had to find a way to. Let me see if I could think this chat. How do I hide this chat, boy? All right, so somebody trying to make trouble. I don't know who it is. All right, doesn't matter. They can't stop this thing in the world. Okay, so let me go back to where I was. Where was I? Where was I? I was here. No, I was here. All right, so well, I think for this question, all you have to do, you need to recognize. I'm gonna give you a hint. It's really quite simple. You have a rectangular block, right? So it's a rectangular. It's a rectangular block, but the one face is actually a square, right? So that's what you actually have. And what they're telling us here is that, okay, so this is like a side, that's like a side. And of course, this is like the height of the block, you could say. Well, it's a rectangular block, so you can see this like a length, that's like a breadth, and that's like a height. So you know the volume of any rectangular prism is what? What's the formula? What's the volume for that?
Length by breadth by height.
Yeah.
Okay. And they're telling us the area is a square. So the two, that's the volume of the block. All right, that's the volume of the block. Right, is this. That's the volume of your block there. And they give you the length of each side of the base, which is a square. And all I want you to do is to get the height. So we know that if volume is length by breadth by height, and the length of the breadth is the same thing, so the volume is actually side by height. And I want to get the height, then I have to get the height will be equal to the volume all over side by side. So I think that will be equal to 4 root 2 minus 3 root 3, that's the volume, divided by side, which is root 3 minus root 2 into root 3 minus root 2.
Yeah.
Right? What to do is to
Yes, sir.
simplify it and then rationalize it.
Oh, yeah.
Make sense?
Yes, sir.
Yeah.
So,
Yes, sir.
so you all should be able to combine the denominators using a plus b into a minus b. You actually have, okay, this one is in the form of a minus b all to b squared. Well, you should know if you do a minus b into a minus b, what do we get, boy? You get a by a squared. Negative b by negative b, you get plus b squared.
Minus 2ab.
Right, minus b by a, minus ab, minus b by the first a, minus ab. So you'll get what? A squared plus b squared minus 2ab.
Yes, sir.
Use that fact there to combine what you have on the bottom there. That's really simple. Make sense?
Yes, sir.
Yes, sir.
Yeah. So, and then you should be able to get it in the form of a number a by root 2 plus b times root 3 after you rationalize it. All right, so I hope you all understand that.
Yeah.
Yes, sir.
Well, see if you get an answer. Then what I want you to do for me, I want you all to, let me see. And tell me what answer you all get in the end, right?
All right.
All right, so let me clear up my, all right, so you've got enough hints there.
Yes, sir.
Right, and let me hear what answers you all come up with. Somebody threw them in my class, plenty boy.
Sorry, sir.
Huh?
That
That's
was
not,
me.
no, that's not you. I seen somebody throw them in my class.
Uh-huh. Like somebody in the class?
Yeah, I was in the chat.
Uh-huh.
Jamil, you wrote you are Coca, the real Maldrandro. You wrote that?
No, sir.
You see the person put your name there?
So I on a YouTube stream, you know.
Yeah, somebody put this Jamil. So
They probably see my name on the chat.
yeah, I realize that. That's what any kind of idiots they have sometimes. Uh, really idle. Wow. Oh Lord. You know, and I know it is, you know. Yeah, I know the student. I know it is. Lord have mercy.
Hmm.
So it's obvious. What I need to do is to stream our classes with a link to keep all these idiots.
Yeah, because they just up on YouTube.
The person definitely has some homosexual tendencies, without a doubt. I know what's wrong with these people. But anyway, the reason why I put the link there really is to um, sometimes, like for example, GL is not in class today,
Mhm.
so she'll be able to see what we did today.
Yeah, I sent her the link.
Yeah. Okay, okay, just have to ignore the chat. I have to find a way to get rid of that chat.
Hmm.
And let me see. How can I delete that chat?
E plus B, E minus B.
Well, then get out yet?
That's a
Almost done. Nearly done. Straight out.
What about you, Jimmy? You still struggling?
no, almost get, almost get.
Okay. Want to see if I get the same answers for A and B.
Mhm.
Yeah, some students in my current class in school in Form 5 who would do this kind of thing.
Okay.
Yeah, some unique children.
Hmm.
This is minus.
Hmm.
Subtract
Okay, so you all know if you all were doing the exam, I'll be woefully behind time, right?
Yes, sir.
Yeah, okay. So I want you to see how much practice you kind of need to do, right? It's a serious thing. I really want you all to see how much practice you need. So let me see if I can work it out, right? So
Mhm.
I basically write something like this. Volume of rectangular prism is equal to, as I said in the question, 4 root 2 minus 3 root 3 meters cube. Okay? I recall the volume of a rectangular prism is length by breadth by height. Let's say that's the base. Right? So it's area by base times height. But I remember also that, but the base is a square. Right? And therefore the volume of that prism or rectangular block is going to be side squared by height. Required to find the height. If you're required to find the height, you can find height by saying right, right, where the side of the square, I'm saying the base is a square, but the side is equal to, what was it? Root 3 minus root 2 meters. The volume prism is that. If you're required to find h, then we can say, we can say, h will be v over s squared. Which in this case will be 4 root 2 minus 3 and root 3 all over root 3 minus root 2 all to be squared. But then we have to recall the laws I told you before. Recall that a subtract b all to be squared is equivalent to a squared plus b squared minus 2 times a times b. So therefore, root 3 minus root 2 squared this would have been like a.
Mm-hmm.
This would be like b. So
Yes, sir.
a squared will be root 3 squared, which will be 3,
3.
Three,
right?
three.
Yeah.
Plus 2
So
minus 2
Minus
square
3.
root 3 by
by
square 2.
root 3 by root 2, yeah. So it's actually really what? 5 minus 2 root 6.
Yep.
Agreed?
Yes,
Yes,
sir.
sir.
All right. So that being the case now, I'll just take a box there. All right. Why do you want to come here? All right. I'll take that and I'll shrink that. And I'll move it. All right. So, right. So why did that? That's just working I was doing in my head. So, all right. So this will be equal to 4 root 2 minus 3 root 3 all over 5 minus 2 root 6. Agreed?
Yes, sir.
Yes, sir.
Yeah. When to rationalize that, that's when they get root sign out the denominator. So this will be equal to 4 root 2 minus 3 root 3 all over 5 minus 2 root 6. I want to rationalize and multiply that by 1. And the one we choose will be 5 plus 2 root 6 all over 5 plus 2 root 6, right?
Yes, sir.
Yes, so that will be
That's where I
4
reach.
2 minus 3 root 3 all over 5 minus 2 root 6 into 5 plus 2 root 6 all over 5 plus 2 root 6. Okay?
Yes,
We know
sir.
the bottom already is in the form of what? A minus B all to B, A minus B into A plus B.
Yeah.
So you know the result is going to be A squared minus B squared, right?
Mm-hmm.
Yes, sir.
So we could just write the numerator as a product now. So this is equal to 4 root 2 minus 3 root 3 all into 5 plus 2 root 6 all over, of course, as A squared minus B squared. So I'll take this as A. This will be A, right? 5 is A and 2 root 6 is B, right?
Yes, sir.
Yes, sir.
So that'll be 5 squared minus 2 root 6
Squared.
all to B squared. Now, 2 root 6 all to B squared is actually really the same as, I'm going to write that over 4 root 2 minus 3 root 3 on top by 5 plus 2 root 6 all over 5 squared minus 2 squared root 6 squared. So that's actually really 4 root 2 minus 3 root 3 into 5 plus 2 root 6 all over 5 squared is 25, 2 squared is 4, 6 squared, root 6 squared is 6. So that's 25 minus 24 there, which is 1. Right? But
21.
yeah, this is the bottom piece is 25 minus 4 6 is 24. That's 1. So you just remain with 4 root 2 minus 3 root 3 into 5 plus 2 root 6. And of course now, you just multiply, right?
Yes,
Yes,
sir.
sir.
Yes, that's that by that. So 5 4s are 20. So you get 20 root 2. Huh? And then 4 root 2 by plus 2 root 6, that's 4 by root 2 by 2 by root 6. Will you agree?
Yes, sir.
Yes, sir.
And then taking this one minus 3 root 3 by 5. 5 3s are 15, so you're minusing 15 root 3. That makes sense?
Yes, sir.
And then this term by that is minus 3 root 3 by 2 by root 6, right? Now 3 by 2 is
Yes.
6. Now let's just see if we can simplify this. So 3 2s are 6. Right, so okay, there's 20 root 2 here. All right, so what we'll do, we take the 6, every time we see 6, we break it up into 2 and 3. Leave it as it
Okay.
is here. So you say 20 root 2 plus 4 root 2 by 2 by root 3 by root 2. This root 3 by root 2 is the same as root 6, right? Minus 15 root 3 minus 3 by root 3 by 2 by root 6. But root
By
6 is
3
what?
by
Root 2 by
root.
root 3. Make sense?
Yes, sir.
Yeah. So let's see what actually happens now. I can take these 2 root 2s here and multiply them. See that?
Yes, sir.
I can take these 2 root 3s and multiply them. And our sum will come down, it will come from that point. So root 2 by root 2 will give me just 2,
Sir.
right? So the first term will be 20 root 2 for sure. The second term, root 2 by root 2 give me 2. So this root 2, by that root 2 will give me 2, right? By 2, 4, by 4, 16. So I get 16 times root 3. That makes sense?
Yes, sir.
Yes, sir.
Yeah. Minus 15 root 3. And this one, root 3 by root 3 is 3. 3 3s are 9 by 2, 18. 18 root 2. Well, of course, you have 20 times root 2, and you're taking away 18 root 2, you remain with 2 root 2. And 16 times root 3 minus 15 of root 3. 16 minus 15 is 1. Right? Or just root 3. And that's the answer. 2 root 2 plus root 3. And how they wanted the answer? They wanted the answer
A and B.
where, right, you have to find the height of the block in the form A root 2 plus B root 3. Easy?
Yes, sir.
All right. Well, it's 4:55 now. What I want you all to do for me, I want you all to try to do question 3 for me.
Okay.
Do you remember how to do number 3, Amka Fancy? Remainder and factor theorem?
Yes, sir.
All right, just try to do number 3 for me. 5, that shouldn't take all more than 5 by what? 1.5, 7.5 minutes. 7.5 minutes should bring all it about 5:03.
So you could bring the questions a little bit, I can see.
Oh, no problem. That's not a problem. Let's do that. Let's know. Boom.
Yes, sir, I'm good. Okay. Minus 2.
Eh, eh. Okay. Candice and Makisha. Nice seeing you all. Listen, I did not. That person who put my name there, Kuka, somebody's we call that trolling me.
Ranim.
Right, Candice. So nice seeing you all. And Prithvi, very nice. And Makisha, very, very nice seeing you all.
So how you know it's them?
It is them. Yeah, those are not trolls. Those are good girls. That person putting Kuka, the real Malandro, that is not Mr. Kuka. Okay, so ignore that person. That person is a real character. A pervert too. Real pervert. Oh, okay, Makisha. All right, okay. So how's everything going? Fine?
Let's see.
Oh boy. It's actually one of my current students. Who's doing that? And the sad part is the person does not know. I'll pray for them.
The expression is
Oh Lord, this person is learning at all.
A and B are constants of factor of we know that because of these ones, we didn't forget that. These are enough 15.
Yeah, those are okay. So I know Makisha, Prithvi, and Candice. Wow, it's wonderful to hear from you all, boy. Great students. Great students.
15.
Oh Lord. Okay, y'all should be in year 3 by now. Yeah, they should be going in year 3 this now.
X cubed plus A and
You should be going finishing year 2 now. I have to find a way to get rid of this coca, the real Madandro. Who's this person, boy? If I don't know who it is. Okay, Makisha, yes, you know I'll be going in year 2. That's correct. Probably Prithvi too. I think Prithvi might have taken a year off. You all can tell me how you get rid of a. I don't like to spend much time. How you get rid of a person on these chats, boy? How you block them?
wow. That's a very good question.
What you could do? Okay. Okay. I see how I can get rid of. Okay, no. What I could do is I can only see them. I can't do anything with them. This coca, the real Madandro. Maldandro. Oh my goodness. I thought Bisham. Bisham have a but Bisham is so idle. This looks like the work of Analdo. All right, so guys, you all getting through?
Yes, sir. I reached the simultaneous equation now.
All right. Okay. What about you, Kafensi? You getting through? Kafensi, are you getting through? Wait. My coca, the real Madandro, don't drop out, boy. Go and take a rest, now, man. We have exams coming up. Go and take a rest. Kafensi, you getting through?
Yes, sir.
Okay. Okay. No, you're getting through. But it's taking too long to get through.
Yeah.
Remember, I told you all. You should have been finished it already. That's why people used to find GC math so hard. Right? Okay, so what we'll do, I'll try and work out that one with you all. I'll give you a couple minutes again.
All right, no problem.
Yeah, factor they get. This is a factor that I use.
When,
Factor theorem.
obviously, when f of x is divided by x minus a, the remainder is f of a. If f of x is divided, so you have to use that concept to get two simultaneous equations to solve.
Mm-hmm.
So what I would have done, I would have let, just to give you a hint, Kafensi, it's not nice to be totally in the dark. All right, so that's the f of x there.
Yes, sir.
And remember for the remainder and factor theorem, if f of x is divided by x minus a, the remainder is always equal to f of a.
Sir.
So now if you are a factor, what the remainder will be?
0.
0. So they say that this expression here, f of x, has x minus 3 as a factor. That
Mm-hmm.
means f of 3 will give you, will give you the remainder, which will give you
15.
0.
Yes, sir.
Then I say when f of x is divided by x plus 2, the remainder is 15. Now the remainder is always f, if it, x plus 2 is what? X plus 2 could be written as x take away negative 2.
Yes, sir.
So this would be like x take away a now, where a is negative 2, and the remainder is always f of a. So therefore, f of minus 2 has to be equal to the remainder, which is 15.
Mm-hmm.
Make sense?
Yes, sir.
Right, so then you have x cubed plus ax squared plus bx minus 3, that's f of x. And then f of 3, f of 3 will be, in place of x, you'll put 3 cubed plus a by 3 squared plus b by 3 minus 3. And that's supposed to be equal to 0. So from that, mm, uh, uh, mm, mm, from that part, you should get an equation that you can
Yes,
solve.
sir. Mm-hmm.
3 cube is what?
Yes, sir.
27.
27.
Yes, so I get 27. 3 squared is 9 plus
9.
9a
9A.
plus
Mm-hmm.
3b minus 3 is equal to 0.
Mm-hmm.
You got that from this first condition where x minus 3 is a factor.
Yes, sir.
And f of minus 2 is supposed to be 15. So if f of x is this, and it means minus 2 cubed plus a into minus 2 squared plus b into minus 2 minus 3 is supposed to give you the remainder, which is 15, right?
Mm-hmm.
Sir.
Yeah, so this part works out to be 8 minus 8. Negative 2 squared is 4 plus 4a minus 2b
2B.
minus 3 is equal to 15, right?
Mm-hmm.
Mm-hmm.
If you take the constants across on the other side, minus 8 minus 3, that's minus 11. If you get on the other side, you have to add it. So I get 15 plus 11, right?
Yes, sir.
Which is 26. So the equation now becomes, this equation now becomes 4a minus 2b is equal to 26. Or if you divide by 2, I get 2a minus b will be equal to 13. If you divide that whole equation by 2.
Mm-hmm.
Make sense?
Yes, sir.
Right, and your first equation would have been, like you have 27 and 3 here. 27 minus 3 is
9.
24. So that'd be
So be
9a
9A
plus
plus
3b
3B.
is equal to minus 24.
Mm-hmm.
And if you
Yes,
divided
sir.
that by 3, you'd have gotten 3a plus 1b is equal to minus 8. Make sense?
Yes, sir.
And you solve these two equations simultaneously.
Mm-hmm.
And you get your answer.
Yes,
So if I
sir.
just solve these two equations simultaneously, what you'll do with them? Subtract them or add them?
That's not.
Just repeat the question, sir.
If I wanted to solve those two equations simultaneously, what would I have done? These two equations, I want to solve that. Oh God, Lord have mercy.
Add. You can add.
I had to add them, yeah.
Mm-hmm.
Because the minus b and the plus b will cancel.
That's right. That's right. Undo that last piece. Oh Lord. Where's my undo button, boy?
So I think you could use Control Z. That'll be like a faster way to undo.
I think so. Let me see.
Yeah.
Wow. Okay. Right. Okay. So right. So I wanted to that equation and that equation. These are two equations you have to solve simultaneously for A and B.
Yes, sir.
Mm-hmm.
So to eliminate B, you add the two equations as he said. So 3A plus 2A will give you what?
5A.
5A. Oh God, I'm using a highlighter. All right, sorry. So I have 5A and B plus minus B will give me 0B. And 13 minus 8 will give me what? 5, right?
Yes, sir.
Yeah, 5.
Yeah, so 5A is equal to 5, 0B is 0, right?
Mm-hmm.
So that means A is
A
equal to
equals
1.
1.
And now I substitute in any of the equations to find B, right?
Mm-hmm.
Yes,
So
sir.
if A is 1 there, 3 times 1 plus B is 8, minus 8.
Yes, sir. So be minor. There'll be
B minus 11
B will be equal to minus 8.
minus 3. B
Yes,
minus
minus
11.
11.
Yeah, minus 8 and 3.
All you get that?
Yes, sir.
All right, gentlemen. I want to make sure and revise all your surds the next day. I want to do
Yes, sir.
logs and indices. We have to be able to do questions like number 2.
Number 2,
Mhm.
okay.
All right,
Yes,
all those
sir.
kinds of equations, right? So let me take that off so you can see number 2 clearly. Right, so just try and revise all you did in logs and so on. Logs, surds, indices. Try and revise all of that. So when you come next week, we could go a little faster.
Yes, sir.
All right, and then we could try these CXC questions and so on. CXC have more questions in logs than they do in surds, at least in the paper 2. Now, you all will be writing exam next year. You all get away from this year. Now, I had the privilege to go and look at exams this year. And from what I see, they just bring back the same thing to multiple choice. Same thing to bring over the years. They have no paper 2, right? You all know because of COVID.
Yes, sir.
Yeah, so
Wait, our year 2?
I very much doubt that.
Oh, well, yeah, okay.
All right, I very much doubt that. Unless COVID makes a resurgence.
Mm-hmm.
And I think in that case, I'll just have the same exam twice. They still may have to make some changes. You might, but questions like number 2, you ought to be able to look at questions like these, right? You all said they would have done logs, so anybody should be able to see that 32 is actually really, everything is powers of 2. That's 2 to the x minus 3 here. 8 is 2 to the power 3, 2 to the power 3, all raised to the power minus x. 32 is actually 2 to the power 5, and 4 is actually 2 to the power 2, raised to the power half x. That's the key to solving this one, right? But revise your stuff for next week so you can get through this very easily,
Yes, sir.
Yes, sir.
right? All right, okay then. So folks, I think that was a good time for us to say adieu.
Yes,
Yes,
sir.
sir.
All right, fellas. So you all take care.
Same to
Have
you,
a
sir.
good one. All right,
Yes, sir.
bye-bye.
Next week.
All
Yes,
right.
sir.
And Akafensi,
Sir?
make sure and give her the link.
Yes, sir.
I think I seen the link there. But you seen the link, right?
Yes, sir.
All right, okay, great. All right, fellas, take care. Have a good one.
Same to you, sir.